Hello, Math 8 students. We are starting lesson 9.1 of Module 9, Properties of Translations. So, in this lesson, we are going to take a look at our essential question here. How do you describe the properties of translations and their effects on congruence and orientation of figures? So as we go through these explore activities and these examples today, by the end of this, you should be able to answer that question. Okay, so moving right into our first explore activity, we are going to be taking a look at translations. First of all, we need to understand what a translation is. So, you learned that a function is a rule that assigns exactly one output to each input. A transformation is a function that describes a change in position, size, or shape of a figure. The input of the transformation is the pre-image, and the output of the transformation is the image. So this is the before or start, the pre-image, and this is the after or end, right? A translation is a type of transformation that slides a figure along a straight line. So this is what we're doing today, is translations. Translations are a type of transformation. And translations slide a figure. Okay, so we're going to take a look at our little coordinate here, our little coordinate grid, and we're going to see that the triangle shown on the grid is the pre-image, input, right, or the starting image. The arrow shows the motion of the translation and how point A is translated to point B. The arrow shows the motion of a translation and how point A is translated to point A prime. So we call this A prime, that little tick mark there. That means it is our image, that means it is our transformation. It is the image after the transformation. So pre-image, and we're going to find out what our image looks like. So we're going to trace a triangle ABC onto a piece of paper. Cut out your traced triangle. So I've got a little triangle over here that I have drawn with some of my tools, and we're going to pretend that it's a piece of paper. So I've traced my triangle, ABC, and I've put it on top of my pre-image. Now I'm going to slide my triangle along the arrow to model the translation that maps point A to A prime. So I'm going to take my triangle, oops, that's not my triangle. So I'm going to take my triangle here and slide it along my line, translating it from A to A prime. So this is where it ends. Now, the image of the translation of the triangle produced by the translation. So this is my image. This is my pre-image. This is my image. This was my translation. So we're going to sketch the image for the translation. So you would cut out your piece of paper and then you're just going to draw where that triangle is. The vertices of the image are labeled using prime notation. For example, the image of A, so pre-image, image is A prime. The image for B would be B prime. So here is B. This would be B prime. And here is C, and this would be C prime. So that indicates to us that we know that this is our pre-image, this is our start, and this is our image, this is our end. So we're going to describe the motion modeled by the translation. We moved how many units to the right? Well, let's take a look. So if we go from A to A prime, we've got 1, 2, 3, 4, 5, 6, 7. 7 units to the right. And how many down? So this is that point. 1, 2, 3, 4, 5. So 7 right and 5 units down. Check that the motion you described in part A is the same motion that maps from A to A prime as it does for B to B prime and from point C to C prime. So B to B prime should be 7 left. 1, 2, 3, 4, 5, 6, 7, and 5 down. 1, 2, 3, 4, 5. And there we are. And C should be the same. 7 to the right. 1, 2, 3, 4, 5, 6, 7, and 5 down. 1, 2, 3, 4, 5. So that translation was the same for all of our points. Now we're going to take a little reflection here. And we're going to think, is the orientation of the triangle affected by translation? So orientation, if you don't remember, is the direction, right? So a way to remember orientation is up, down, left, right. Did it spin? Did it change? Or using a compass, north, east, south, west. Is the north still north? Is the south still south? Is the east still east? Is the west still west? Is my A still the top? Is my B still on the right and down? And is my C still on the left and down? Yes, the orientation did not change. So with translations, orientation does not change. It is not affected. The orientation stays the same. Okay, so that's just a quick look, introductory look at translations. We slid a figure on straight lines to the right and straight lines down. We have our pre-image, we have our image. Orientation did not change. Let's go ahead and look at our Explore Activity 2, which is properties of translations. So we're going to use the trapezoid, TRAP, to investigate the properties of translations. So we've got another trapezoid here. And let's see, I've got a ruler sitting over here. I'm going to move this trapezoid right here because it wants me to trace a trapezoid onto a piece of paper and cut out my traced trapezoid. So here's my traced trapezoid right here. Now I'm going to place my trapezoid on top of the trapezoid in the figure and then translate my trapezoid 5 units to the left and 3 units up. So let's map that out here real quick. 5 units to the left and 3 units up. So I'm going to go ahead and pick this point right here, and you could pick any point you want. I'm going to go 1, 2, 3, 4, 5 units to the left and 1, 2, 3 units up. So now if I move my trapezoid 5 units to the left and 3 units up, this is the new location of my trapezoid. Okay? Now I need to label my vertices, which are my corners, right? So if this is T, this would be my T prime. This is R, R prime, A prime, and P, P prime. Okay? Now we've got to do some measurements. So if you don't have a ruler at home, you're just going to follow along with me. And I've got my ruler. I'm going to use my centimeters to measure this. And the first thing I'm going to do is measure the side lengths of my pre-image, so my initial image here. First thing I'm going to do side TR, then RA, then AP, and then TP. Okay? So I'm going to get my ruler here. I'm just going to place my 0 on my corner, and then I'm going to rotate my ruler. And so you can see that this is 1 centimeter here. But I'm a little more than 1 centimeter, and so I'm just going to actually look down here at the bottom. These are my millimeters. So this would be 1 centimeter here. And it looks like I am sitting about 1.2, between 1.2 and 1.3. So I'm going to go ahead and write 1.3 centimeters for that side length. Now I'm going to measure RA. I'm going to go ahead and slide my ruler. Whoops, wrong way. Get that back in line. Slide my ruler, rotate this way. So I've got my side length for RA. And so if I'm looking here, I've got 1 centimeter, not quite 2 centimeters. So I'm just going to cut across here and see how many I've got. Looks like I'm at about 1.6, 1.7. So I'm going to go ahead and put 1.6 there. And these are approximations. You might get a little bit more, a little bit less on either side. So 1.6 centimeters. I think the book says 1.7, but we're pretty close here. And then I'm going to measure side AP. So I'm going to move my ruler again. Line it up. I'm going to put it on this side here. Rotate my ruler, measure it out. So I've got 1 centimeter and then some, so I'm just dropping across here. It looks like I'm at 5, 6, 7, about 1.7. Make sure you're putting your correct units there so we know what we're measuring in. And then doing side TP. I'm going to rotate that up. So I've got 1 centimeter and then almost 2. I'm just going to cut across here and see what I've got. 5, 6, 7, looks like about 1.8 centimeters. Okay? Okay, so we've measured our pre-image. Now it wants us to use a ruler and measure the side lengths of our image. So let's take the ruler over here. I'm going to measure them all out again. So TR, we'll start with TR. Whoops, wrong way. I'm going to move this over just a little bit. Try and line these up. Okay, and so I'm going to measure that. Looks like I'm about at 1.3 again for T prime R prime. So that side length is the same. Can you make a guess on what all these side lengths are going to be like? Did we change size at all? We did not change size at all. So let's go ahead and measure this one. Looks like, again, we come across, we're sitting at about 1.6 centimeters. So far, we're looking at the same. Slide down for side A prime, P prime. Line things up. Looks like we're sitting right here at 1.7 again. And then one more rotation. Pretty close, right across. Looks like we are sitting at about 1.8. Okay, so you could find that there might be a little bit of error depending on how accurately you cut out your trapezoid or didn't cut out your trapezoid. So there's a little room for error, but what you should find is that the side lengths are the same for translations. So right here in question E, what do you notice about the lengths of the corresponding sides of the two figures? The lengths of the corresponding sides are the same. Oops, spelled that wrong. Let's go back. Yes. Okay. So now we need to use a protractor to measure the angles. So I'm going to slide this down just a little bit. And we're going to measure the angles of our pre-image, so our initial image here. Drag my protractor over here. And this is why we need to do that practice protractor use. The first angle I am measuring is angle T, so this angle right here. So I've got to make sure that I've got everything lined up. So I've got my center in my center. I've got a ray lined up here at my 0, and then I'm going to see where that arrow points. And I'm looking at, so this is 110, this is 100, so between 100 and 110, I'm going to estimate about 105 approximately, okay? Let's make sure I've got things lined up. Yeah, so I'm going to say about 105. And I need to use my degree symbol. Okay, I'm going to measure angle R now. So I'm going to move this over, center, line up my rays. And this is a 90-degree angle. So it's right here in this corner. That's 90 degrees. Slide it down, measure this angle, angle A, rotate my protractor around. This is another 90-degree angle. You can see it lines up there. And then I'm going to measure angle P. So I'm going to slide over here and just spin my protractor around and line it up again. Okay, so I've got about 70 degrees, it looks like, maybe 73. Let's check my alignment here. Oops. Yeah. About 75, 73 degrees. Let's go ahead and just keep it at a clean 75. Okay, so we are now going to compare these angles to the angles of our image. So we're going to start with angle T, line things up, spin around, and we are looking at, oops, let's move this. Oh, whoa, what's going on? There we go. We're looking at about the same angle here. It's pointing it there between that 100, 110. So we're looking at about 105 again. And then we're going to measure angle R. I'm going to slide over here to angle R. Spin it around, make sure things are lined up. And we've got another 90-degree angle. Those 90s are so nice to measure. Slide down, measure this next angle here. Line up my rays. Looks like I've got another 90-degree angle. There we go, lined up a little better. Yep, another 90-degree angle. And then we're going to measure our last angle here, slide over to angle P. You can see I'm not quite lined up here. I need to shift a little bit. And again, we're looking between 70 and 80 here again, so we're about 75 again. So what do you notice about the measurements of the corresponding angles? What do you notice about them? They are the same, right? So if we look at T and T prime, 105 degrees, R and R prime, 90 degrees, A and A prime, 90 degrees, and P and P prime, 75 degrees. So the thing that we notice about these two measurements of corresponding angles is that they are the same. The measurements of corresponding angles are the same. So we're going to go ahead and write that in here. So, side lengths are the same, angles are the same. Now let's go ahead and answer this next question. Which sides of trapezoid TRAP are parallel, and how do you know? So looking at, I'm just going to scroll this up here a little bit. If we look at our original image here, our pre-image, we can see that parallel is two lines that run at the same angle and never touch, right? They have the same slope and never touch. So these two lines right here lie along horizontal grid lines. This means they have the same slope. And this means they were never touched, which indicates that they are parallel, right? So that would be line TR and line PA. So we know that line TR, and this is how you indicate that, TR with a line over it, and AP are parallel. We know this because they both lie along horizontal grid lines. Let's go back. Which means they have the same slope, right? So which sides of TRAP are parallel? TRAP prime, right? So of our image. Well, we can assume that since the side lengths are the same and the angles are the same, that the same corresponding sides would be parallel. They also lie along they also lie along horizontal lines. So we would say, with this notation, line T prime, R prime, and line A prime, P prime. So what do you notice? The sides that were parallel in the pre-image are the same in the image. So the lines that are parallel in the pre-image are also parallel in the image. So we know now with translation, which is sliding along a straight line, we do not change orientation, we do not change the length, the side length, and we do not change the angles. So it's essentially the same shape in the same orientation, same size, just in a new location. So we're going to make a conjecture here. If your results from part E, H, and I, to make a conjecture about translations, and that's just what we just said here. So translations preserve, that means they don't change, size, shape, and orientation. Only location changes. So nothing else changes. Only size, shape, and orientation all stay the same. Location changes. So if two figures that have the same size and shape are called congruent, what can you say about translations and congruence? So a translation that produces a figure that is congruent to the original figure. So translations, let's say with translations, the pre-image and image are congruent. Right? So this is something you want to remember, right? So same size, same shape is congruent. So you want to commit that to memory. That's important. So what we've got down here is this is how you walk through translating, right? If you are translating a figure from a location, what you're going to do is move each point the number of units that they were indicated to be translate. So the figure here, we need is XYZ, it's triangle XYZ, and we're going to graph the image, so the after a translation of 4 units to the right and 1 unit up. So each point goes 4 units to the right and 1 unit up, 4 units to the right and 1 unit up, 4 units to the right and 1 unit up. So what they did here is they translated each point and then named that new point with its prime notation. So this is X over and up, X prime. Y over and up, Y prime. Z over and up, Z prime. And then you're going to connect your points. And you should end up with a congruent triangle in a new location. Same size, same shape, same orientation, different location. So what I want you to do now is I want you to do this your turn. Okay, and we will go over this in class tomorrow. So this is what I want you to try on your own, and we'll go over it in class tomorrow. We'll also do our guided practice together in class tomorrow. That is it for notes today. They are a little bit longer. Taking those tools took a little bit of time. Hopefully you were able to move through and just check work as you needed. If you have questions, please make sure you wrote them down along the way. If you didn't write them down, please go back and note where you had questions so we can go over them together. All right, so that's it for 9.1 notes. We'll check your turn tomorrow in class, and we'll go over the guided practice tomorrow in class before you start the assignment. All right, guys, I will see you in class tomorrow.